All right, hi there. So what we're going to do is we're going to go over the cycle shot problem. Remember what I told you in class. I want you to try parts A, B, and C on your own first. So if you have not done that yet, pause the video, work through the 3 problems on your own, and come back when you're ready to check your answers. But if you are ready to check, let's go ahead and get going. I'm going to start by giving you the answers for parts A, B, and C, because what we need to do is we need to determine what parts of the video you need to watch, okay? So for part A, there are 16 tricycles. For part B, there are 11 tricycles and 13 bicycles. Now for part C, there's a total of 67 tricycles, 32 bicycles, and 45 tandem bikes. So you're going to go ahead, grade your paper, and let's figure out how many parts out of the 3 you got correct. Before we move on, I do want to bring to your attention, though, that you need to make sure you label your answers. For part B, for instance, it says how many bicycles and how many tricycles are in the shop. It is not appropriate to write your answer as 11, 13 as an ordered pair, because that does not answer the question of how many tricycles and bicycles. So it's really important that with these applications that you label your answers and answer the question. So if you got all parts A, B, and C correct, and you understand them and you did them on your own, you can go ahead and stop the video and you are finished, okay? Maybe you got parts A and B correct, you can fast forward the video until I talk about part C. Or you can go ahead and stay with me and we'll just start over with part A and we'll run through each part, okay? So use this video, pause, fast forward to whatever that you individually need for these 3 problems. All right, so let's start with part A. On Monday, you counted 48 tricycle wheels. Here comes the question word. How many tricycles were in the shop? When we start all of these problems, I'm going to begin by figuring out what I want my variable to represent. So we're going to let X equal the number of tricycles. It's very difficult to write an equation with variables if you don't know what that variable represents. So now we're going to make an equation that represents 48 tricycle wheels. Well, how many wheels does each tricycle have? Well, obviously here that each tricycle has 3. So if we take 3 wheels times the number of tricycles, that's going to equal the total number of wheels in the shop. We divide both sides by 3, and that's where I got 16. Now we're not going to leave our answer as X equals 16. We're going to label our answer and answer the question, how many tricycles? 16 tricycles were in the shop. All right? So what we're going to do next, let's go ahead and go to part B. On Wednesday, there were no tandem bikes in the shop. There were only bicycles and tricycles. There are a total of 24 seats and 61 wheels. How many, now here's the question word, how many bicycles and how many tricycles are in the shop? That's my entry point. Define your variables, okay? Let's go ahead and let X continue to be the number of tricycles. Let's bring in a second variable, Y, to represent the number of bicycles. My first equation is going to represent the number of seats in the shop. So how many seats does a tricycle have? A tricycle has 1 seat, a bicycle has 1 seat. So we're going to say 1x, in fact, I don't really need to write the 1, but we're going to say x plus 1y is equal to 24 for the number of seats. How many wheels are in the shop? Okay, well, a tricycle, as you know, is going to have 3 wheels, and a bicycle only has 2 wheels. So my equation is going to be 3 wheels times the number of tricycles, 2 wheels times the number of bicycles, and that will equal 61. So from here, we solve the system of equations. This could be a really good substitution problem. It's a good elimination problem. It's really just pretty an overall easy problem. I'm going to go ahead and use elimination, and I'm going to multiply the top equation by x, okay? So we get -3, I'm sorry, I said multiply by x, but we're going to multiply by -3. So we get -3x minus 3y is equal to -72. This bottom equation is being multiplied by +1, so it is going to stay the same. Let's add our equations together, and x's eliminate, and we get -1y is equal to -11. Divide both sides by -1, and that's where I came up with the number 11 bicycles, okay? Remember, it's not appropriate to leave it as y equals 11. Make sure you label your answer. So what if we took our y equals 11 and plug it back into one of the equations? Well, I think the top equation would probably be the easiest. X plus, let's plug 11 in for y, is equal to 24. And when I minus 11 from both sides, that's how I got x equals 13. And x, again, represents the number of tricycles. And so that's where I got my answer for part B. Now, let's run through part C. So a month later, there are a different number of bicycles, tricycles, and tandem bikes in the shop. There's a total of 144 front steering handlebars, 378 pedals, and 320 wheels. All right, here comes the question word. How many bicycles, tricycles, and tandem bikes are in the shop? Let's make sure you understand your variable. X is the number of tricycles. Let's continue to let y equal the number of bicycles. Let's bring in a third variable, z, to represent the number of tandem bikes. Okay? Now, if you're listening to this in part C, then it's possible that you solved this incorrectly the first time around. So the first thing I want you to do is let's check your equations. We're going to write an equation for the number of front steering handlebars. Okay? So let's look at our pictures here. How many front steering handlebars does a tricycle have? Just one. Bicycle has just one. A tandem bike only has one front, okay, steering handlebars. It's the keyword front, which is why I'm only going to say that there's one of them. So your first equation is going to be 1x plus 1y plus 1z is going to equal 144. How many pedals does each type of bike have? Okay, well, a tricycle has 2 pedals. A bicycle is going to have 2 pedals. A tandem bike, though, is going to have 2 pedals for the first rider and 2 pedals for the second rider. So a total of 4 pedals. So let's make this equation. 2 pedals per tricycle, 2 pedals per bicycle, and 4 pedals per tandem bike. And that's going to equal 378. Finally, with wheels, a tricycle has 3 wheels, a bicycle has 2 wheels, and the tandem bike has 2 wheels. And that's going to equal a total of 320 wheels. So this right here is the system that we're going to be solving. If you realized right away your mistake was with writing the system, then maybe you want to pause the video and go ahead and try to rework the problem. Otherwise, if you want to go ahead and stay with me, I'm going to walk through how to solve this 3-variable system. Now bear with me for a minute. I had to switch pages so I had more room. I'm going to write out my system. One thing I noticed, though, is I have one of those types of problems where I have 3 equations and all 3 equations have all 3 variables. So this really lends itself to a good elimination problem. The first thing I'm going to do is I'm going to take the first and second equations. X plus y plus z is equal to 144. And 2x plus 2y plus 4z is equal to 378. And what I'm going to do right here is we're going to eliminate. I mean, all of the variables honestly are equally as easy, but I'm going to go ahead and just eliminate the first variable I see, which is going to be the x. So this top equation is getting multiplied by -2. The bottom equation is basically getting multiplied by 1, and it will stay the same. So let's distribute -2 to every term in this top equation. 144 times -2 is -288. This bottom equation is going to basically stay the same. And we're going to add our equations. Well, this is interesting. When I go to add, my x's eliminate, but what I also notice is my y's happen to eliminate. And we get 2z is equal to -288 plus 378, and it's going to equal 90. And so divide both sides by 2, and this is kind of rare, but we end up getting our first variable. All right, so that's how I got 45 tandem bikes. Now the second thing that I'm going to do is I am now going to use the second and the third equations. 2x plus 2y plus 4z is equal to 378. 2x plus 3y plus 2z is equal to 320. And since we already know what the z is going to equal, okay, since we already know, what I can do is I can plug a 45 into this z, and I can plug a 45 into this z, and then we'll have a two-variable system. So let's keep going, and let's see what this is going to look like. This equation is going to be 2x plus 2y plus 4 times 45. Okay, I'm going to go ahead and do 4 times 45, and I get 180, and that equals 378. Now, let's go ahead and minus 180 from both sides, and here's the first equation. 2x plus 2y is equal to 378 minus 180, which is 198. Okay, same thing. This equation is 2x plus 3y, and I'm going to multiply 2 times 45 right here and get plus 90, and that equals 320. So let's minus 90 from both sides, and this is the second equation. 2x plus 3y equals 320 minus 90, which is 230. So this is the two-variable system that we're going to end up solving. You know what? This to me looks like a good elimination problem. Let's just take our top equation and let's multiply by -1. Negative 2x minus 2y equals negative 198. The second equation is going to stay the same. Add your equations together, x's eliminate, and it equals 1y equals negative 198 plus 230, and that's where we come up with the y equals 32. All right. And then finally, we can go back into one of the original equations, and we can plug in our z, we can plug in our y to find x. Well, the equation that I like going back into is maybe this first one, x plus y plus z equals 144. All right, so I don't know what x is, y is 32, z is 45, so let's go ahead and take a minute, combine like terms. X plus 77 equals 144, and when I subtract 144 to minus 77, this is where we come up with 67. Now again, we cannot leave our answer as x, y, and z. We need to finally go back and we need to answer the question. It said, how many tricycles, bicycle, and tandem bikes? 67 tricycles, because we decided that x represented the number of tricycles. 32 bicycles. And finally, we ended up with 45 tandem bikes. And that right there is my final answer with all of the work. Okay, so we'll continue on in class working with applications, but I hope that helped. See you next time. Bye.